Hello guys, Winston here. One question I've seen periodically and a subject I've been meaning to touch on sooner is how to set up a chamfer operation. Specifically in Fusion 360, though some people have asked if it's possible in other programs like Carbide Create, which it is, but I'll discuss that later. Chamfer operations are super useful for breaking sharp edges on parts in addition to adding a more refined aesthetic to a finished piece. Though you can draw up chamfers in Fusion 360's modeling workspace, you often don't need to. When using 2D chamfer operations, you can select the contours of an unchamfered edge to bevel and the toolpath offsets are calculated from there. Let me run you through the relevant parameters with a quick example. I'm going to make a really basic block, 1 inch square and a ½ inch tall. Then I'm going to go into my CAM workspace, define a setup with no extra stock, and apply a 2D chamfer to the top edge. I'll select a 90-degree V-bit to use for this operation, and for the purposes of this example, I'm ignoring the feeds and speeds. I'm going to set the chamfer width to 1/8 of an inch, the tip offset to 0, and disregard the chamfer clearance as it doesn't apply in this scenario. If you hide your model and show your stock in the simulation, you can see that this generates a toolpath which perfectly goes through the corner of your block, leaving you with a chamfered edge. At least, in the simulation it does. In practice, this is a terrible toolpath. Remember how we talked about feeds and speeds a couple videos ago and how surface feet per minute was a function of RPM and diameter? Well, at the tip of a V-bit, your effective diameter is pretty darn close to 0, which means you're going to have a really tough time getting clean cuts. That's where tip offset comes into play. This value controls how far off your tool is from the profile of your chamfer. Increase it, and Fusion will push your end mill out and down so that you're cutting a chamfer with a section of the end mill that has greater tangential velocity. But while you might be tempted to max out your tip offset to optimize for SFM, there are two cases where you might not want to. The first is if you have concave features with small radii. This knob that I machined has numerous circular indentations that have to be chamfered by a cross-section of a V-bit with a smaller effective diameter than the indentations themselves. If you have any inside corners in your design, you'll want to put a radius on those too. Another factor to consider is if you have features below your chamfer. Since the tip offset results in both a lateral and vertical displacement of the tooltip, you need to be aware of potential collisions caused by this. Going back to an older project, I had a ledge right below a chamfer operation that I didn't want to hit, so I picked the largest tip offset I could get away with. I'm sure longtime machinists have plenty more tips about chamfering, so if you're watching, feel free to drop some knowledge in the comments section down below. But this wraps up all dang it, I forgot about you Carbide Create users. Carbide Create doesn't directly support chamfer toolpaths, but you can fake them with a little trigonometry. You know that the programmed end mill diameter affects how far offset the center of a toolpath is from a nominal profile. 1/8 inch end mills run a 1/16 of an inch off any given wall, 1/16 inch end mills cut 1/32 off center, etc. You also have direct control over depth of cut. So tell Carbide Create to use an end mill of a calculated radius even if you have to make one up, but mount your V-bit instead. If you got your numbers right, it'll chamfer a profile just like Fusion 360 would. And that is everything I wanted to discuss about chamfers. There's plenty more to say on that topic, but I think you should now have enough information to get started with them and learn the rest through your own experience. Thank you all very much for watching, and if you have any suggestions for Fusion topics in 5 minutes or less, drop them in the comment section down below. I'll be back with more CNC related content in a week or two.